Hello everyone, welcome to my channel. This is Naresh Chennu. In today's session, we'll see the problems related to the resistive networks and star delta conversion. In this lecture, we'll see from basics. So first one is star delta transformation. So in star delta transformation, we'll convert star is given, we'll convert it to delta, delta is given, we'll convert to star. So these are the formulas which will apply to find the resistance values. If you see here, the delta formed with RC, RB, RA. So RA, RB, RC formed with delta. If you see R1, R2, R3 values, R1, R2, R3 formed the star. So if you want to find delta values, you should know the star. If you want to find the star values, you should know the delta values. Means this is one-to-one conversion. How we will convert, we will see. So here it is a star. First one I will convert star to delta. In star they will give the star and we have to find the delta. So to find RA, RA is for what? RA for delta RA. So here the trick is, first when you are going for star to delta, you remember this S. So S is sum of known. This is what I mentioned here. This is known sum. Which sum? This R2 and R3. Because if you see this RA, this is formed between R2 and R3. So we have to write known sum, that is R2 plus R3, and their product R2 into R3 divided by remaining, which is not covered in this path. So that's what I wrote. So if you see RB, because this is the delta of RB. So RB again it is covered R1, R3. So this sum R1 plus R3 and their product R1 into R3 divided by remaining is R2. Now if you see RC is again between these two, R1 plus R2 plus their product divided by remaining is R3. That's what I mentioned here. Here no need to by heart all these formulas, just you apply what I told by using this logic. This is about star to delta. When we have delta, we have to convert to star, means delta is given, we have to find the star. So in that case, what we do is, compared to this conversion star to delta to star is easy. So we want to find the R1 is here. So simply we multiply these two, RA into RB, and sum of the all resistance values. That is only our R1. If you find R2, here it is R2, simply we'll multiply these two values of delta, RA and RC, and divide by sum of R, means you have to find R1, R2, R3, sum of these three values. In next problem we'll see, I will show you this. So R3 is, here it is R3, again these two product, means RA into RB divided by sum. This is all about converting star to delta and delta to star. Now we will see the problem. Now first problem I will give homework to you. Now we will see here, this is what? Star. You have to find the delta here. So star is given, you have to find the delta. I will take this RA, RB, RC, or you can take R3, R2, or R1. This R1, RA, the values are not fixed. So what I mean to say is, if you by heart these formulas, will confuse about this R1, R2, R3 and RC, RA and RB. What I have to put, whether I have to take like this, that and all will get the confusion. So that's why I'm not using any formula, directly I will apply here. If you see, now we want to find the RA. What it is given, this is star to delta. What I told, first remember as sum of these two, means these two, 30 plus 20, 20 plus 30 plus their product 20 into 30 divided by remaining is what 50. This is only our answer of RA. 50 600 by 50. So we have 62 ohm is RA. The value of RA is or R1 is 62 ohm. Now we'll find value of RC or R3. We'll take RC here. Again RC is covered between these two. So now again sum of 50 and 20 and 50 into 20 divided by remaining what 30. If we solve we will get the RC. Again RB. This is RB of delta. Again sum of what these two. Because this in between only this is the RB. Here it is in between of 20 30. Here it is in between 20 and 50. Now RB is 30 plus 50 and their product divided by remaining what 20. So this is all about star to delta. Here why I give homework is if you do this we will get RA, RB, RCE values are 3 times 10 ohms. Because when all the values are equal we will get every value in the delta is 30. Check this shortcut. Because when all are same we'll get in delta that is multiplied by these values. That's what you should verify. Now we'll go from delta to star. Now I will make here one star. So I will take this R1, R2, R3. Again this is from delta to star. Simply we'll multiply. R1 is between what? Between this 12 and 12. So 12 into 12 divided by sum of all resistance 12. This is 144 divided by 36 means, or we can do for your simplification again 144 by 36 will be time waste to put 12 into 12 divided by 36. This is 4 ohms. If we find R2, again R2 is covering between these two, again we will get 4 ohms. R3 also will get 4 ohms. Because when you are having the same values of delta same values in star, that value divided by 3 ohms will get. That's what result. If it is 4 ohm 12 ohms I got all 4 ohm 4 ohm 4 ohm. We can verify also. See R2 is between again 12 into 12 divided by 36. Again I got 4 ohm. This is what the shortcut means. Whenever the all values are same, while you are going from delta to star, simply divide that value divided by 3. If you are going from star to delta, whatever the same values multiply by 3. So here is multiplication, here it is division. Now we will see other type of question. The dependent source in the figure is what? Already I explained earlier, this triangle represents the dependent source. This arrow represents the current. So this is current source. And controlled by whom? This I0. I0 is what? Current again. So totally it what? Current controlled current source. Current controlled current source. D is option. Just to see which is current source or voltage source and the controlled variable. Now again we'll see the power related question. Here is very important. That's why I mentioned again here. Now the idea of power observing of element is always you see the current direction where it is entering. If it is entering at positive terminal of the element, then power is multiplication of current and voltage. That is power observing. So first question we'll do. So here it again it is entering at positive. So simply we'll write power equal to Vi. What is V? Voltage 10, current is 40 watt, power observed. We'll see, always focus on here only. If it is going like this, leaving means is entering at negative terminal. It is entering at negative terminal because here it is, here means it is entering. This is entering at negative terminal. So that case power equal to minus times Vi. Now how much V is 12 volts and 2 minus 24 volts. Power observed minus 24 volts. This we can write 24 volts supply of power also. Yesterday I told the power observed equal to minus times of power supplied. So here also we'll see. Now we see here minus 3 amps entering at negative terminal. If you have any confusion, we can write minus 3 amps like this. I can write plus 3 amps like this. So simply I have changed the, see, in network theory, this is 3 amps means the direction of the current like this means minus 3 amps. This conversion we can use. If it is minus 3 amps like this, we can use amps like this. So it is coming like this in 3 amps. I have taken, sorry, it is coming like this minus 3 amps. I have taken this plus 3 amps. So again, current entering at positive terminal of the elements. So power observed equal to E times I, that is 15 watt. So this is all about power observing and supplying. Next we'll see the equivalent resistances. This manner means the one end of one resistor connected to the other end of other resistors and so on. In this fashion, if we connect, this is one resistor, one more resistor will connect like this and so on. This is series configuration. This is series configuration. To find the equivalent resistance across these two, A and B, we should add the two resistors. That's why I put the equivalent resistance between A and B, RAB equal to R1 plus R2. For example, I have taken one example here. It is 5 ohm and 10 ohm. This connection is series. One more thing is that if you identifying the series or parallel connection, you assume some current is going here, I. So same I is going here also, and current is continuing up to here. So in series connection, the current is same in all branches. So if you take these two in series, so the equal resistance is R1 plus R2. So we got 15 ohms. Second one is parallel. If two resistors are connected in this fashion, we'll call this is parallel connection. In parallel connection, the total current I is dividing between these two resistors. If it is I2, it is I1. So that we can tell in parallel the current is dividing. And if you see the equivalent resistance between here across A and B, we got R1 into R2 divided by R1 plus R2. This is a formula we will use when two resistors are connected in parallel. So for that one I gave one example. This is 5 ohm and 10 ohm. Here if you see this I, it is dividing here I1, it is I2. This is like in the network, if 10 amps going, here it is divided here and the 10 amps will divide here. So in parallel connection, current is dividing. So for that one, to find the equivalent resistance, we will use this formula. As per this formula, 10 into 5 divided by 15, we got 10.3. But in our network following upcoming problem, we don't use this formula. Directly we will use this shortcut. That one is, if you see like these two resistors are connected in parallel. See, this is 20 ohm and 10 ohm. This I will assume like a one resistor R. And if you see 10 ohm, it is half of 20 ohm, means R by 2. In that case, to find the equivalent resistance, we got the R by 3. That is directly 20 by 3. This is the answer. Simply, this is, you take X. This is X by 2. our resistance is x by 3. That's what I have done here. For one more is R is 40 ohm, and one more resistor we have it like in this fashion. You want to find the equivalent resistance here. This is 40 ohm and this is 10 ohm. This you take R, this take R by 4. R you take this x, this is x by 4. X is 40, x by 4 is 10. So finally what we get here is, this is AB. How much we'll get? 40 divided by 5. We can prove also, see, 40 into 10 divided by 50. So what we got? 40 by 5. This is 8. Here also 8. By using this formula or by using this shortcut, we will find the equivalent resistance. This is all about finding the equivalent resistance. Now we will see one problem based on this formula. Now if you see here, see now to find the equivalent resistance across these two pins. Here we have to find the equivalent resistance. To find the equivalent resistance, we'll go from back like this. We'll go. Now if you see, these 4 ohm, 5 ohm and 3 ohm are connected in series. So series connection means this will be added. How much will get? 4 plus 3 plus 5 equal to 5, 8, 12 ohm. So here we got 12 ohm across this. Now if you see, this 4 ohm and 12 ohm are in parallel. Up to here we got parallel resistance of, now I will take one more slide and just explain you nearly. Now here we'll see, now to solve equivalent resistance, see 4, 3, 5 are in series. So here how much we'll get is, up this combination will get 12 ohm. So 12 ohm is parallel with 4 ohm resistor. So if we see here RAB, 12 ohm parallel with 4 ohm resistor. Again, you know, this is R, we got this is R by 3. Equivalent will be R by 4. So 12 divided by 4, we got 3 ohm here. How much we got? Here we got 3 ohm. Now this 3 ohm resistor and 3 ohm resistor in series. So 3 plus 3, here we got is equal to 6 ohm. We got here up to 6 ohm. So here we got again this 6 ohm, this 6 ohm in parallel with again one more 6 ohm resistor. What we got? These two are in parallel again. So 6 ohm parallel with 6 ohm. How much will get? 3 ohm. This is also one more shortcut we can use. Two resistors are same. This is also R. This is also R. We will get equivalent is R by 2. So here we got 3 ohms. Here we got. So finally our circuit will be. So this we got finally 3 ohm. This is 2 ohm. This is 1 ohm. See, now all are in series. If you see, all connections are series. So simply this is 2 plus 3 plus 1. This is 6 ohm. Answer for this question is 6 ohm. See, to find the equivalent resistance, simply you see here what are the connections are there. After that again you see it is parallel. Again our resistance what we found is in series with this. Finally it is parallel. So finally we got this circuit. So like this we have to solve the equivalent resistances. So we'll see next question. This is also same to find the equivalent resistance here. Now if you see from here, these two are in parallel. So 20 parallel with 5. How much we got? This is R. This we got R by 4. Because 20 20 by 4 equal to 5. This is what we have here. So R by 4, answer will be R by 5. So 20 by 5 equal to 4 ohms. So these two we can replace with 4 ohms resistor. So now if you see this 4 ohm and 1 ohm in series, so 5 ohms we got here. Here it will be 5 ohm, and we have one resistor from here to here. These two are in same, so I will write like this. This is 20, and we have here 2 ohms. Again we have here, right. So what we got here is 5 ohm, here it is 20 ohm, it is 2 ohm, 9 ohm. So now again we can simplify this. Again same, 20 in parallel with 5, we will get 4 ohms. Here 4 ohms, we can replace this circuit with 4 ohms. So now this is 4 ohms. So 4 and 2 are in series, means we will get 6 ohm here. Now we will get 6 ohm, 9 ohm, and we have one more. I will extend the circuit. Now what we got here, we got 6 ohm parallel with 9 ohm. Here this 9 ohm, again 18 ohm resistor. So if you see these two are in same connection, so that's why these two are in parallel. Again like this. So finally we have 8 ohm resistor. We have to find the equivalent resistance here. See again, here we have 18. If you see these two, I can take this R and this R by 2. How much I'll get? R by 3. Means I can replace the 2 with 18 divided by 18 and 9 in parallel. So how much will get? R by 3. Means here I will get 6 ohm. Again already this 6 ohms, it is 6 ohms only. This 8 ohm. Again you have to find here. Now if you see again, these two are in parallel. 6 in parallel with 6 means R in parallel with R. How much will get? R by 2. So 6 in 6 parallel will get 3 ohms. So this is 8, this is 3. What is our answer now? Simply 8 plus 3 equal to 11. This way we will do, because we will not use any time here R into R into R1 divided by R plus R1. That formula will not use. Just we'll see the connections. If you see these two, it is parallel, and this is with series. Again this combination parallel. So like this we will solve the networks. For this question, answer is we get 11 ohms. So same thing, one more question in same fashion. I will do this in fast manner. See again, 1 and 5 are in series. So how much will get here? Here we will get 6 ohm. Now if you see, this pull is one node only. So this 12 ohm also we can replace this 12 ohm with same. We can connect here this 12 ohm. Simply we can connect here. So now our circuit will be this. What are the 6 ohm? 4, this 12 ohm, 6 ohm. Up to here I wrote. Again this 6 ohm parallel with 3 ohm. Then later we'll see. Now if you see here up to here, again I will use that R by 2 will get R by 3. Means 12 parallel with 6. How much will get? R, this is R by 2, will get R by 3. Means 4 ohms. Here these two we can replace with 4 ohms. So this entire network will replace with now 4 ohms. Again we know 4 parallel with 4. Again we will get 2 ohms. So this entire network is replaced by now 2 ohms. So now up to here we got 2 ohms. Now 2 ohm and 1 ohm in series. Yes. Now I will write this one 10 ohms. 3 ohm. You see here. Up to here we solve the network. So 10 ohm. This is 3 ohm. This is 1 ohm. Here we have 1 6 ohm resistor. What we got finally is 2 ohms. Up to here we have solved the network. The 6 ohms I have taken here, 12 ohms I have taken this side. So we got, now see, now this 2 ohm and 1 ohm in series, the equivalent will be 3 ohms. Now equivalent will be 3 ohms. Now if you see again, this 3 ohm, 6 ohm, 3 ohm are in parallel. First I will take these two. How much will get? 1.5. So I will take these two. For easy calculations we will take these two. Sorry. So now I will take R parallel with 3 ohm. This is R. This is R by 2. We'll get finally R by 3 means 6 by 3. We'll get 2 ohms here. So these two will replace with 2 ohms. So finally our answer will be 10 plus 3 parallel with 2 ohms. So 10 plus, this is what? 3 into t by 5. 10 plus 6 divided by 5. It will be 11.2 ohms. For this question answer will be 11.2. Simply we are done. These two are in series. Again this is parallel and this form 12 ohms also parallel. Like that we done. Finally we achieved finally this circuit. So in resistive networks we have to follow this, like where it is series and where it is parallel. Slowly we'll reduce the network to small like this. We'll see one more problem. This is also very simple problem, but here we have to find the I as well as R equivalent. So what he is asking is, here we have to find the R equivalent. To find the R equivalent of that circuit will be, see, to find the I we have, we'll get the circuit in this manner, 3 ohms. Finally this is what we are finding the R equivalent, 3 ohm, 10 volts. This is I. To get the I we should use this I equal to 10 divided by 3 plus R equivalent. So we need R equivalent. Now we will find the R equivalent. To find the R equivalent, again we'll go from this side. So now 2 plus 1 in series. So finally this 3 ohm will come into parallel like this. So 3 ohms and 6 are in parallel again. How much we'll get here? 6 parallel with 3. How much? 2 ohm. Like R is again R by 2. We got R by 3 is 2 ohms. Here we got 2 ohms. Like, so if you see, this is 4 ohms, 2 ohms. This is 3, 6, 2. Here we are finding R equivalent. We see these two replaced by 2 ohms resistor. Now I will replace this with 2 ohms resistor. This is 2 ohm. Again if you see now, this 2 ohm and 2 ohm and series. So entire network will replace with 4 ohm resistor. This is now 4 ohm. Now finally R equivalent will be 4 parallel with 4. How much will get? R will get R by 2, means will get 2 ohm here. So R equivalent will be 2 ohms. So we got R equivalent is 2 ohm. Now the current I equal to 10 by 3 plus R equivalent 10 by 3 plus 2. Now 10 by 5 equal to 2 amps. So we got current equal to 2 amp. R equivalent is 2 ohm for this network. So this is simple. Find the R equivalent here and finding the I by using the method of reduction of network by using R equivalent. To make the circuit easy, we are finding the R equivalent. So for your understanding, I have mentioned all the formulas here. You can go through once. Till now what I explained all I have mentioned here. So what is the series R1 R2? If it is parallel, what? Here Z is nothing but conductance, which is reciprocal of resistance, or we can write R equal to 1 by G. Sometimes they can ask you G and finding R, or they will give R and they will ask you to find Z. So again, voltage division, current division, delta to star, star to delta. These are I covered in my previous slides. So I hope you have understood all the concepts, and if you have any suggestions or query, please comment below and please subscribe my channel. Thank you for watching.